Okay, let's try this again here. So yesterday we went over some of these rational exponents. It means your exponent for your exponential is a fraction. And there you go, here's your fraction, and we looked at some of these definitions. So today we're going to see how we use this second definition here. And let me remind you here how this works, that you have an index value, right? That's the denominator of your power. And that's going to be the index for your radical. So we're going to write these as radicals here. And the m value, the numerator here, right, this m is going to be on the outside. So we're going to see how we use this today. And we'll go over some of these kind of questions. So the first question we have here is 36 to the 1/2 power. Now, what do you guys remember about yesterday? How do we write this? Right as a radical, right? Let's go back here and make sure. The index is 2. Is that right? So this will be the square root of what? 36, right? So take a look at your index value. That's the 2. And you already know what the square root of 36 is. That's going to be what? 6. So this is done. Okay, so you guys are supposed to evaluate these. And we're simply going to use the radical form to evaluate. Okay, and that's pretty much it. So, question 3, 81 to the 1/2 power. Again, your index is 2, right? So this is going to equal square root of 81. Okay, see that index, the denominator? And the square root of 81, you guys know, is what? 9. Good. So you can evaluate these now. And this is a useful skill. 100 to the 1/2 power, right, is the square root of 100. Right, your index is 2. So what's the square root of 100?
10.
That's 10. There you guys go. Right, number 7. 9 to the what? 1/2 power, well, that's the square root of 9. Notice the index, the denominator is 2. So this is the square root of 9, which gives you 3. Good. What do you guys think? Is that easy?
Yes.
Okay. Number 9. 64 to the 1/2. Again, that's the square root of 64. 2. Do I have to put the index of 2 if we know it's the square root? Right? What do you guys think? I could just write this as what?
Regular square root?
Yep. And square root of 64 is going to be 8. Okay, now look at this. 64 to the 1/3 power. So this is going to be the cube root now of 64. So notice again, your denominator is the index for the radical. So that's a cube root. So we have to remember, what's the cube root of 64? Right? Is that 4? How do you know?
4 times 4.
Yeah, 4 to the 3rd power is, and 4 times 4 is 16. 16 times 4 is 64. So you can check. So a lot of times for some of these, if you're not quite sure, just go back and write that as an exponential to double check. Okay, because you may not be so familiar with a lot of these answers, and it's okay. That's how you double check. And at this point, if you had to break out your multiplication algorithm for 16 times 4 up here, right? See this? Then do so. And 4 times 6 is 24. 4 times 1 is 4 plus 2, that's 64. So yes, it turns out to be the cube root of 64 is going to be 4. Okay, you guys okay with that one? So this is going to be a pretty interesting homework. 13, that's 125 to the 1/3 power, which is the cube root of 125. So 3 cube root. So what's the cube root of 125? Good. Okay. 15. 1 to the 1/3 power is a cube root of 1. So what's the cube root of 1 going to be?
1.
All right. 17. This is new. 16 to the what? 1/4 power. Is that true? So this will be the 4th root now of 16. So notice the 4 as the denominator is my index. This is a 4th root question. So like we talked about before, they can actually increase that index, and you could look at 4th roots, 5th roots, 6th roots, any root. You don't have to put those lists on the refrigerator, right? You don't have to memorize every perfect 3rd or perfect 4th or perfect 5th at all. All you have to know is the process. So you want a number that's raised to the 4th power that gives you 16. So this is saying x to the 4th is 16. What is the value? Or some base of the 4th is 16. What's the base? You guys take a guess. What could it be? 2. So what's 2 to the 4th? 2 times 2 times 2, right? And then you say, okay, 2 times 2 is 4. 2 times 2 is 4, right? What's 4 times 4? So what does that mean? That means, ladies and gentlemen, the 4th root of 16 is really this number right here, right? It's really what? 2. So for some of these, you're going to have to go back and do that. Okay. In fact, if it's the 4th root, it's not on your list, right, on the refrigerator. 5th root, 6th root, all those roots aren't there. You just go back to the definition, find the perfect 4th, right? So anybody have any questions on that one? No? So 19 now, we have 256 to the 1/4 power. So that's the 4th root of 256. So again, we need a base to the 4th power that gives us 256. Now, I don't know about you guys, but I don't remember what this might be. I know it's not 2 because 2 to the 4th from the prior question is 16. So what do you think it could be? What should we try? What base should we try? 4? Okay. So if we wanted to try 4 and we said, okay, what's 4 to the 4th? Well, 4 times 4 times 4 times 4. 4 times 4, isn't that 16 times another 16? Okay. So I don't know what 16 times 16 is. So we break out our algorithm, right? 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 1 times 6 is 6. 1 times 1 is 1. So we get 6, 15. You guys are right. It's 256. So what's the answer, though? 4. Good. So this answer is going to be 4. So we're taking the 4th root. Good. So 21 now. We got -8 to the 1/3 power. And remember, that's going to be the cube root of -8 now. So if you guys remember, you can take, since this is the index 3, it's the denominator, it's 1/3, we're going to take the cube root of -8. Can you take cube roots of negatives?
Yes.
Yep. And have it be a real solution? The answer is yes. What is this? It's -2. And you might say, why again, right? Because -2 to the 3rd power, we're saying has to be -8. Well, -2 times -2. So negative times a negative is a positive. Positive times a negative is a what? Negative. So your answer is -2. Okay. Good. We're at 23 now. So notice they give us -27 to the 1/3, which is the cube root of negative 27. Go back and see. Cube root. So yeah, it's going to be what? Negative 3. You guys had a test on these kind of things. Right? So remember, you could take cube roots of negatives. That means negative 3 again to the 3rd power. It's going to be negative 27. And it is. Okay. 25. Negative 216 to the 1/3 power, or 25. So that's going to be the cube root of negative 216, right? Because I have a 3 down here. That's my index. It's a cube root. And what is the cube root of negative 216? Is it positive or is it negative? Is it a negative 6? Well, we don't sound too confident. So what should we do? We should check this. Is that right? So you say negative 6 to the 3rd power will be negative 6 times negative 6 times negative 6, which is 36 times negative 6. My answer is going to be negative because a positive times a negative is a what? Negative. I just have to find the value. So let's multiply. 6, 36, 6 times 2 is 18. Oh, negative 216. So you guys are right. It is negative 6. That's good. Boy, we're going to get to do a lot of our homework. 27. Oh, this is what we want to do here. This is new. This is where we use our definition of, a rational power, a fraction power. Remember, this is the nth root raised to the mth power. This is what you guys want to use to evaluate this. So let's go back again. See, the n is still my index, but outside my parentheses, I have that m here because remember the properties that we talked about? Right? Because remember this was b to the 1 over n. So we worked on these properties the other day. B to the 1 over n to the mth power, you just multiply your powers, right? 1 over n times m will be m over n. So this is what we're using. So you have now 36 to the, take a look. That's the 3rd power. That's going to go outside here. Is that right? And then if you look at this index of 2, or the denominator, which is 2 here, that means you're going to have the square root of what? 36. Okay, so let's take a look at that. That's where your 2 goes. And so now we know, okay, I have to take the square root of 36 and then raise that to the 3rd power. What is the square root of 36? 6. This is 6 to the 3rd power. So to answer the question, this is 6 times 6 times 6, which is 36 times 6. Now, I don't know what that is. I'm going to have to what? Multiply. So 6 times 6 is 36. 6 times 3 is 18, plus 3 is 216. So ladies and gentlemen, this answer here is 216. So we can evaluate exponentials with rational fraction exponents. Okay, the powers are fractions. We can evaluate them. Anybody have any questions on that one? That one's new. We're using this property. So this was number, what, 27? Okay. 29, we have 81 to the 3/2 power. And again, we're going to evaluate. So remember, the 2 is in the denominator position. The 3 is in the numerator position. So what power do we put outside here? Good, we put the 3. Okay? And then so inside we have what? Square root of 81. Good. And I want you guys to focus on that portion. That's what we're using here. So you know what the square root of 81 actually is. What's that? Is that 9? So this is 9 to the third power. So I'm going to have to multiply 9 times 9 times another 9. Now, isn't 9 times 9 81? So 81 times 9, what did you guys get? 729. Look at that. So ladies and gentlemen, this answer is 700 and what? 29. So you evaluated this rational exponent kind of question, right? The power is a fraction, 3 halves in this case. So we can do this kind of all day long, right? 31, 100 to the 3 halves power. This is going to be the 3's outside, and then what do you have here? Square root of 100. Let's make sure that the numerator is on the outside. The denominator is my index for the radical. So I get this. What's the square root of 100? 10. So this is going to be 10 to the third power, right? And you guys should know, what is that? It's 1 followed by 1, 2, 3 zeros. So yes, it's going to be what? 1,000. Okay, you guys okay with that one? So 33 here. Nine to the 3 halves is, let's make sure we do this correctly. All right, this is going to be 3 is on the outside, and then this is what? 2. Square root of 9 is what?
3.
And this is 3 to the third. Okay. 3 times 3 times 3. Right, 9 times 3, this is going to be 27. So you guys evaluated this rational exponent. $35. 64 to the 2/3 power. So notice how this one changes here. Right, your numerator 2 is still on the outside here. And we're going to use the index of 3. So this is going to be a cube root question. It's the cube root of 64. So that's cube root. So we're going to notice that. And so what was the cube root of 64? That's 4. So this answer is really 4 to the second power, because we still have that power on the outside of 2. It's still there. So now 4 squared becomes 4 times 4, which is what? 16, and you're done. $37. 125 to the 2/3 power will be. Let's be careful. So remember, the numerator power, that's a 2, it's outside. The index of 3 here means we actually have a cube root of 125. Okay, let's make sure we have the cube root. What's the cube root of 125? 5. This is 5 squared now. Remember that power still. And 5 squared we know is 5 times 5, which will give you what? 25. So that's number 37. $39. 8 to the 4/3 power. We're going to write, keep the 4 outside. This is the cube root of what? 8. 4 outside, and then you have a 3, 3. So what's the cube root of 8?
2.
2, so this is 2 to the 4th. Which is 2 times 2 times 2 times 2. And then that's going to be 4 times 4, you're right, is 16. So we can evaluate these. 39. 41. So 41, 216 to the 4/3 power. Okay? So keep the power 4 on the outside. This becomes a cube root of 216. 3, there's the index. This is the power on the outside. It's a 4. So what is going to be the cube root of 216? Is that 6? So we got 6 to the 4th power. Don't forget that 4 is still out here. So 6 times 6 times 6 times 6. So remember, I don't know what these answers are. I just know how to multiply. And that's going to be, if I multiply these two, 36 times 36. So we bring out our algorithm. 6 times 6 is 36. 6 times 3 is 18. What's 18 plus 3? Is that 216? Then 3 times 6 is 18. 3 times 3 is 9 plus 1. Isn't that 10? 6, 9, 2, 1. So we get 1296. And you say, what about a negative 64 to the what? 4/3. Let's use the definition. Right? This will be to the 4th power. This will be the cube root of negative 64. 4 on top, and then you have the 3 here. So what is the cube root of a negative 64?
Negative 4.
It's negative 4, and don't forget your 4 power is still there. So we have to multiply negative 4 with itself a total of 4 times. So if you guys remember, you got all these negatives, right? You got negative times a negative times a negative times a negative. That gives you a nice what? Positive. So I'm not going to worry about my sign. I just worry about 4 times 4, which is 16, times another 4 times 4, which is 16 again. Does anybody remember what this was? 50. What is 16 times 16? 256. I'm sorry. I thought I heard 56. And you guys are done. What do you think? Evaluation is pretty easy? Okay. 45. Negative 125 to the 4/3 power. So again, by definition, make sure the 4 there is outside. This numerator is outside your parentheses. And you got now the cube root of negative 125. So here's our denominator, cube root. What's the cube root of negative 125?
5. Negative 5.
Yep, negative 5. So I have negative 5 now to the 4th power, which will give you negative 5 times negative 5, right? And it's in the same situation where we have negative, 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 negative. Your answer is going to be positive. So we just got to multiply our 5s together. Yeah, so we get 25 times 25. We've seen that to be 625. So this is how you answer some of these questions. (47) Negative 1 to the 4/3. Keep the 4 outside again, right? Power 4. And this is going to be a cube root now. You got a cube root of negative 1. 3. Cube. That's negative 1 to the 4th power.
I'll say 1.
Yeah. So the answer is positive because you got negative times a negative. You got 4 of those, right? And then we have to just worry about what's 1 times 1 times 1 times 1. Isn't that just 1? So there you guys go. Okay, 49. Now it's going to get a little interesting. Okay, we got 100 to the minus 1/2 power. It's going to get interesting here. This is what I mean by interesting. Remember what we looked at the other day too? Any base to a negative power is 1 over the base to the positive power. Okay, do you guys remember this one? Ah, okay. All right, so this is going to be 1 over 100 to the 1/2 power, which is 1 over, what do I write down? Isn't that a square root of 100?
Yes.
Right? Your index here is 2. So what is the square root of 100?
1 over 10.
Yeah, so the denominator is going to be the value 10 here. But your final answer here, don't forget that you have a 1 on top, right? Final answer is going to be 1/10. There you go. What do you guys think? Okay. 51. 125 to the negative 1/3 is 1 over 125 to the positive 1/3, right? Now the definition here on the bottom of 125 to the 1/3 power, you guys know, is the cube root of what? 125. Is that right? This is my 3. There's my index. So what is the cube root of 125? Isn't that, it'll be, what is it?
1 over 5.
5? Okay. So what's your final answer, though? The denominator is 5. My numerator is 1. This is 1/5. Okay. So 53, we get 256 to the negative 1/4 power. 1 over 256 to the 1/4 power. Now, 256 to the 1/4 power here, ladies and gentlemen, look at the index 4, right? That means I have the 4th root of 256. So what is the 4th root, right? This is the index. What is the 4th root of 256? Is that 4? Okay, so the denominator here is 4. So this final answer is 1/4. 55. 36 to the minus 3/2 power. That's 1 over 36 to the positive 3/2. Okay? So by definition, this is going to be square root of 36, and that's going to be raised to the 3rd power. So now what we have here is what we were looking at recently. The 3 here is outside. Is that true? And then you have this index. The denominator 2 is your index, so that's a 2 there. So you guys know. So I have 1 over, I need to find out what the square root of 36 is. What's this?
6.
So this becomes 1 over 6 to the 3rd power. And if you remember, 6 times 6 times 6, what is this? 36 times 6 is 216. Is that true? So your final answer is going to be 1 over 216. Okay, you guys okay with number 55? (57) 9 to the minus 3/2 power. 1 over 9 to the 3/2. What's the definition here? This is 3. This is going to be what? Square root of 9. Okay, remember? Numerator 5 is on the outside. The denominator has an index of, or the value of 2, which is my index for my radical. So 1 over, what's the square root of 9?
3.
So this is 1 over 3 to the 3rd power. Don't forget that power here is still there in blue. Yeah, and then that denominator here, right, is 3 times 3 times 3, which is 27. So your final answer will be 1 over 27. It's 57. (59) 27 to the minus 2/3. 1 over 27 to the positive 2/3. So we're going to use the definition. 1 over, what's the power on the outside going to be? You guys know?
3.
Right. What's this numerator? Is that 2? Okay, so then don't forget, we have to write the cube root of what? 27. That 3 is in my denominator position, so that's my index. Okay, you guys okay with that? So now you can say we have 1 over something squared. What's the cube root of 27?
3.
3, good. So 1 over 3 squared. We just need to know what 3 squared is. What's 3 squared? 3 times 3, which is 9. So what's your final answer?
1 over 9.
1 over 9. So this is number 50 what? 9. Okay. (61) 8 to the negative 2/3. By definition, is going to be 1 over 8 to the positive 2/3. Is that true? Or just using our property. Any base to a negative power is 1 over the base to the positive power, right? So some of these, remember, we're using this property. And now by definition, we have 1 over, what power goes on the outside here? 2. Good. Because the numerator is 2. That's where the numerator goes. Is that right?
Yes.
And since my index here, or the denominator here, is 3, I'm going to now have the cube root of 8. And yeah, we know the cube root of 8 is what?
2.
So this number is 2. Don't forget the 2 power is still there. So this is still there. Okay, so this number here is what we just found, in case you guys didn't know. Cube root of 8 is going to be 2. Okay. So 2 squared now is 4. So the answer is going to be 1/4. That's 61. Okay. We have a base to a negative power. How do we write that? It's 1 over the base to a positive power. Oops. And it's not 3/2, it's 2/3. Okay. So remember here we have that numerator 2, denominator 3. So we're going to replace this with the power 2, right? That's the numerator. And then now we have a cube root of negative 27 because we have the index being 3. So that makes it a cube root. Okay, you guys okay with that? Now, what is the cube root of negative 27? So positive 3 or is it negative 3? Remember, you could take cube roots of negatives. So that's negative 3 to the second power. So don't forget your power 2 is there. Yeah, so we have 1 over negative 3 times negative 3. And you guys happen to know that's going to be what number? 9. Is that true? So you have 1 over 9. All right. 65, negative 216 to the negative 4/3 would be 1 over negative 216 to the positive 4/3. So we're going to have to write this as 1 over, remember, the 4 goes out here. Is that true? And then what goes inside here? Cube root of negative 216. So 3 and what? 3. So if I can answer this question, I just raise that answer to the 4th power. Now remember, this is negative. We could take the cube root of a negative number. The answer is going to be negative, right? What is the cube root of a negative 216?
6.
Is that negative 6? So don't forget the 4th power is still here. And then this is negative 6 times negative 6 times negative 6 times negative 6. So again, negative times negative times negative times negative, that's a positive, is that right? So I'm just worried about 6 times 6 times 6 times 6. And what is that?
36.
Right? Remember this is 6 times 6 times 6 times 6. We got 36 times another 36, right? Anybody remember that answer?
1,296.
1,296. Good. Is that what it is? Should we double check in case we don't know? It's always good to practice your arithmetic. 6 times 6 is 36. 6 times 3 is 18. Plus 3 is 216. 3 times 6 is 18. 3 times 3 is 9. Plus 1 is 10. 6, 9, 2, 1. And you guys are correct. That's how we answered number 65.